Hello बच्चों, let's read this question. Question says, from the given table, answer the following questions. Reaction is H2O gaseous plus CO2 gaseous is in equilibrium with H2 gas plus CO2 gas. Here we have to calculate enthalpy of reaction at 298 Kelvin, change in enthalpy of reaction at 298 Kelvin, calculate change in Gibbs free energy for this reaction at 298 Kelvin, change in entropy of the reaction at 298 Kelvin and change in internal energy of reaction at 298 Kelvin. Also calculate the value of entropy of H2O gaseous at 298 Kelvin. Here in this table the data are given, and here we can see that data for H2O entropy, data for entropy for H2O is missing. Now we can calculate one by one. So we will take firstly the first part. We have to calculate change in enthalpy of reaction at 298 Kelvin. So firstly we will write our key concept. In this we can write that enthalpy of reaction at 298 Kelvin, it is equals to summation of enthalpy of product minus summation of enthalpy of reactant. Here the datas are given, so we can write the datas here. So at product side we have H2 and CO2. For H2 the value is 0 and for CO2 the value is equals to minus 94.05. So we will write minus 94.05 plus 0 minus, for reactant side here carbon monoxide and H2 are present. For carbon monoxide the value is minus 26.42 and for H2O the value it is equals to minus of 57.8. So from calculation the value of change in enthalpy of reaction at 298 Kelvin comes out to be, minus 9.83 kilocalorie per mole. Now we have to calculate for second one. So the secondly we have to calculate the change in enthalpy of reaction, change in Gibbs free energy of reaction at 298 Kelvin. So we can write that the value, that key concept it is equals to change in Gibbs free energy at 298 Kelvin, it is equals to summation of del G at product side minus summation of del G at reactant side. Now the values are given in this question. So at product side here H2 and CO2, for H2 the value is equals to 0 and for CO2 the value is equals to minus 94.24 minus at reactant side here it is values are minus 32.79 for CO, minus 32.79 plus minus here the value is equals to minus 54.64. Minus 54.64. So the value of change in Gibbs free energy at here, the value of change in Gibbs free energy at 298 Kelvin comes out to be minus 6.81 kilocalorie per mole. Now we have to calculate for the third part. Here the third part is, here we have to calculate for third part. The third part is we have to calculate change in entropy of reaction, change in entropy of reaction at 298 Kelvin. It is equals to, so we can write here in this the key concept. Key concept is del G is equals to del H minus T del S. Now in this question we have the value of del G and del H and also the temperature, so we can calculate the value of del S. Here del G is equals to, we already calculated the value, it is equals to minus 6.81. Now the value of this del G is in, that is Gibbs free energy change, it is in kilocalorie per mole. So we will multiply by 1000 so that the value convert into calorie per mole, and the del H value is also in kilocalorie, so we will write here minus 9.83 multiplied by 1000 minus the temperature is 298 multiplied by the value of del S. This we have to calculate. So we can calculate the value of del S from here. So the del S comes out to be, it comes out to be minus 10.13 calorie per Kelvin per mole. Now this is our third answer. We have to calculate the fourth one, that is we have to calculate change in internal energy of this reaction at 298 Kelvin. So we know that del H is equals to del E plus del Ng RT. Here this del E is equals to change in internal energy. So firstly we will calculate the value of del Ng. So del Ng is equals to summation of number of gaseous moles of product side minus summation of number of gaseous moles of reactant side. So at product side, here number of moles we can calculate, that is, here we can see that H2 gas, that is 1 mole, and CO2 gas, that is also 1 mole. So here 2 moles at product side are present and 2 moles at reactant side are present for H2O and CO, that is carbon monoxide, for 1 1. So we can write 2 minus 2. So this comes out to be 0. The value of del Ng is equals to 0 here. Now we can write that del H, it is equals to del E, because this value is equals to 0, so this will become 0 here. Now the value of del H is equals to minus 9.83, so the value of change in internal energy at 298 Kelvin, it also comes out to be minus 9.83 kilocalorie per mole. Now the fifth part of the question, in this we have to calculate that entropy of H2O gaseous at 298 Kelvin. So entropy of H2O gas at 298 Kelvin, this can be calculated. We have the change in entropy at 298 Kelvin. Now we can write that change in entropy at 298 Kelvin for this reaction, this can be written as summation of change in entropy at product side minus summation of change in entropy at reactant side. Now we can substitute the values in this. So this value, it is equals to minus 10.13. So minus 10.13, it is equals to, at product side we have H2 gaseous and CO2 gaseous. For H2 it is equals to 31.2 and for CO2 the value is equals to 51.1 minus the value for CO is equals to 47.3 and for let's say for H2O the value is equals to X. We have to calculate this value of X. Now we can write minus 10.13, it is equals to, this is equals to 82.3 minus 47.3 minus X. Now we can write this minus 10.13, it is equals to 35 minus X. So from here we can calculate the value of X. This comes out to be 45.13 calorie per Kelvin per mole. So these are the explanation of your 5 parts. Hope you understood it well. All the best and thank you.